Practices. A big shift for students and teachers in implementing the NGSS is the focus on the 8 practices, meaning that students are not only responsible for knowing ideas, but they are responsible for engaging in practices that use the ideas in authentic ways.
When it was raining, the mud might have got wet. So then when the bike was riding, it might have left the track because the mud was wet, and then it the wheels got down into the mud, and then it left a track.
How can a teacher enable students to use and show the scientific practices in more and more sophisticated ways?
The water is really
There were some challenges. There were some students that were really disappointed. I could tell that I wasn't saying, that's right, you're right on, or no, you're not exactly right, try again. They were looking for me, and it was hard for them. But they did learn from that experience that unexpectedly certain students who don't talk a lot had something to say.
puddle, and yesterday, and it rained, so there's a puddle.
The idea that kids are scientists and kids can make their own science and come up with their own ideas and their own explanations, and that it was generated here in the classroom. Being part of that, facilitating that as a teacher, that kind of developing agency of students, I think is one of the most exciting things about NGSS.
Look at these cards that you made yesterday. They may not be the exact cards that you made.
Molina's students start with writing claims with evidence. They are working toward listening for the evidence in the claim, working collaboratively, and taking risks.
Rolando, what do you have?
Because wet from
Even though this practice was new to Molina, she worked to support it using sentence strips and student-gathered photos for evidence.
Suppose you wanted to make a claim. What do you want to know? So suppose you wanted to ask yourself, did it snow last night? That would be what you're thinking. Thinking about things that are easier to see, like snow. So that's what you think. And then the evidence would be why you think that. What did you observe?
Another practice the students engaged in was predicting phenomena, which was part of planning and designing the investigation, and then explaining the predictions.
How does that compare to your prediction? So it did it. Interesting. Who's in the gravel group? What was your prediction when we pour the water on it?
float. The water will go on the rocks. There'll be a mud in there, and then the rocks are gonna probably float.
The rocks are gonna float?
And they're gonna change color.
Huh. Okay, let's see. Very nice job.
It changed color. It's more darker.
Is it a river on the rocks?
No.
No.
The predictions allowed the students to show how their thinking was developing. The NGSS show that practices lead to other practices and that they cannot occur in isolation, just as scientists participate in multiple practices in the real world. The practices work together along with the disciplinary core ideas and cross-cutting concepts to allow students to explain phenomena.
What do you think?
I don't agree.
You don't agree? Do you want to say anything more about that?
I don't agree because there's water and there's not normally water there. But it doesn't change the land.
What else about that? What can you say?
Doesn't change the land because that's hard.
And so why does that matter?
Because then the land doesn't change. Concrete can get changed sometimes because it can get cracks.
What do you think, Sandy?
Change.
Okay, how come?
Because here is dry, but when it's gonna rain, it's gonna get wet, so it's gonna change.
Okay, I'm gonna put it here. I'm gonna put it here.
I disagree.
Yeah? Oh, she disagrees. Okay, why do you disagree?
Because, it wasn't, maybe the day before that day, it was raining, but now it's dry, so if it doesn't rain again so much, Let's say.
Notice how Melina supports argumentation. This practice can be hard to facilitate for teachers because it means that we have to be comfortable with the students being in a space of productive uncertainty. Facilitating this practice is one of the big shifts for teachers.
If one person is saying something, we have to figure out how are we going to not say yes or no, but get another student to respond. I think that's the biggest challenge, but it's also one of the most rewarding. So every now and then you get the kids kind of having a back and forth about an idea that's interesting and important to them. And to be able to sit back and allow that to happen and have that happen every now and then is really exciting. Stand up with your group. You're going to videotape what happens.
The investigation was carried out on the schoolyard, which contained several of the different surfaces that the students had described.
Who was in the concrete group?
The students gathered data about how water interacts with different surfaces.
What's the prediction for this surface? What's going to happen when we pour the water on it?
It's not gonna change.
Not going to really change because
It's hard.
it's hard and so
Change of color.
might change color.
It made a river. Whoa. No, a river is like a line.
Did the prediction come true? Alejandro, did it stay like a river?
Yeah, but it was good to change color.
The unit also called for the students to develop and then refine a model of the schoolyard and its surfaces,
Okay, and then here on this side is the garden.
showing on the model
Here.
how rainwater interacts with the different surfaces.
And then here's the hill. Where's the bakery? Can you find it?
Where the cars are.
So who knows where there is concrete, gravel, grass, and wood chips around our school?
There's concrete right here. There's grass right here and right here. And there are wood chips right here. Right here. Yeah, but no, that whole thing. Yeah, there's gravel right here.
How would we show the grass? Let's start with that.
Coloring it.
How could we do that so we don't spend an hour coloring, but we just show that this area or that area has some grass in it? What do you think?
We can write it grass.
Okay, that's another idea. That's interesting.
Or we can use the markers and then put green around it.
Or we could put green all around it. Yeah, Ada.
Green line.
Green lines.
Really?
What did you think of her idea? Give it a try. Does someone want to go look for a gray marker?
Me. I have a gray marker.
Oh, that's cool.
I love it.
Nice.
Running. It looks like someone cut the lawn.
Is there grass anywhere else?
Yeah, there's grass around here. And there's
Who can do the gravel? Gray for gravel. Okay, Rolando, why don't you give it a try?
What do those dots mean?
rock.
Does it make sense that could show a surface?
Yeah.
That you can make dots and it means something?
What symbol should we use for the wood chips, or what pattern?
Little rectangle. That looks like a
Oh, what do you think about that? Little rectangles, what Adamari said.
Yes.
What are we missing?
Concrete.
Concrete, concrete.
Concrete is the building up here. Yeah, but it's brown.
What color should we make the concrete?
Gray.
But we used gray for the gravel. Huh?
No.
Yeah, do we have any color piel?
No.
We found some color piel crayones the other day.
Why don't we use red?
Or what about red?
Yeah, that's the wrong color.
What kind of symbol should we use for the red in the concrete?
I don't know. X's.
Okay, let's do it. Let's do it.
They used the model to explain that water flow causes different changes to various surfaces on the schoolyard, and there are patterns in the changes they found.
Which surface did you pour water on?
That one.
On the concrete? And what happened with the water? Alejandro, do you remember?
It's spread out.
Oh, it spread out. How so? Tell me more about that.
I made it in one space and then it was spreading out.
How far did it go?
Like about, I don't know, this.
Could you maybe show on our map what the water did?
I made it about right here and then it went about this much.
Could we show how it moved or how it spread? Oh, putting some arrows in there.
What's that? What's arrows?
You know what an arrow is, like a flecha, to show that it moved out in all directions.
Oh, I put it right here. It just stayed there.
How could we represent those two different things on this map?
Put a circle on where we poured it.
Could you do that, please? So, okay, in the gravel, a circle means that it just sunk in.
And I think I know what happened.
What do you think?
I think when you put the water, there's like, the rocks are like spaces that then got filled like this. The rocks are like this and the water went through them and went down.
If there's holes in between the rocks and it made the water go down, if that's what happened, how does that compare with concrete? Is there a difference between concrete and the rocks then? Because concrete is made out of rocks. Why doesn't it go down into the concrete?
Maybe because the concrete is like together, so there's no ways the water can go down, but the rocks, there's like space for the water to go down.
Again, this practice gave rise to other practices, including the final assessment that was a model, explaining how the wood chips that were placed under the tire swings were spread out after the rain. At first, Melina and her students were uncomfortable with productive uncertainty, but they rapidly adjusted. How are you supporting inclusive, respectful discussion about the practices in your class?